Our next presentation is from Dr. Bill Andrews. This is going to help you validate information you encounter about longevity and know if it's truly quality. It is important to know what is real and how to discern facts from fantasy. Dr. Bill Andrews is a molecular biologist and gerontologist whose career has centered on searching for a cure for human aging. He is the founder and president of Sierra Sciences, and in the 1990s, he led the team at Geron Corporation that was the first to successfully identify the genes for the human enzyme telomerase. Please welcome Dr. Bill Andrews.
Hello, everybody. I'm Bill Andrews. I'm the president and CEO of Sierra Sciences. I hope you enjoyed my talk yesterday. Today, I want to talk about how to know what's real and not real, or how to separate fact from fantasy. There's a lot of misinformation in the literature. I'm sure everybody's become especially aware of that, especially now with COVID going on. We hear all kinds of things happening. And so to begin this presentation, I just want to talk about one thing, and that's ivermectin. Okay, I'm actually not going to be talking about ivermectin. I'm just going to say, I'm sure everybody's heard news about ivermectin recently, but I'm not going to give the answers. I'm just going to tell you how to know what's real and what's not real. And that's the purpose of this presentation. So ivermectin has been in the news a lot. I'm sure almost everybody has seen this in social media, what can happen from long-term use of ivermectin. And I wouldn't be surprised if a lot of you have actually decided, just because of this picture, or this social media advertisement, that ivermectin is not a good thing. I'm not going to say whether it's good or bad. I'm just going to say you really probably shouldn't listen to social media. It's not the best place to get your information. I'm going to be showing you how to get that information. And I'm not going to tell you is ivermectin good or bad. I'm going to let you find out for yourself. But there's been a lot of things in the news lately, like breaking. This is just a little over a week ago. Breaking. Federal government doctor says government doesn't want to show the COVID vaccine is full of whatever. I mean, there's a lot of news stories coming out like this. And then we also hear the opposite, that the CDC study of vaccinated frontline workers show COVID-19 shots effectively prevent infection, not just symptoms. So we're hearing both sides. They both can't be right. Okay, somebody's not correct. Okay, but there's all this news coming around, and how is anybody supposed to know what's real and what's not, and what's fact and what's fantasy? Okay, and then just last week, government whistleblowers came out and said that there's a conspiracy to suppress injury and death data from COVID-19 vaccines. I've actually been contacted by several doctors asking me to sign a petition in support of this. I'm not going to, but there's just a lot of misinformation. A lot of top people, a lot of doctors are spreading different messages to people, and it's really next to impossible to figure out what to know, what is real and what's not real. But it's not just about COVID. Even with the subject of aging, we're seeing studies saying aging process is unstoppable, finds unprecedented study. So what that's great for me. It says that everything I'm doing, I would never succeed at curing aging. But then other studies say aging's already been cured. Human aging reversed in the Holy Grail study, scientists say. Again, these are all recent news reports that you've all read. And here's the problem. We're all victims of hearsay. That's what's the problem. At all levels, top levels in government, top levels in official organizations like the FDA, the CDC, WHO. There's a lot of hearsay coming from these organizations, even though you would not expect that. But what is hearsay? Hearsay is really, you hear something, you say something. You hear something, you say something. And it's amazing how this just gets caught on, where everybody starts believing everything. And I'm going to come up with a few reasons right now. The problem is actually twofold. The reason why there's a lot of misinformation being spread is there's problems with the speakers and there's problems with the audiences. Well, one of the things you often hear is that there's conspiracies. I personally don't go there. I personally can see a lot of reasons to suspect that it's not conspiracies. I think there's just confusion, just a lot of people, even at top levels, just getting confused. I've personally seen it a lot of times in my own companies that I've worked at and companies that I work at now, my own company that I'm president and CEO of now. I've seen miscommunication. Okay, so one problem is that a lot of people are competing to be superheroes. They all want to be, in the end, go down in history as being shown that they gave the best advice. And so people are competing for this. This is one of the problems for the misinformation. And then a lot of the experts who claim they're experts aren't really experts at all. Sometimes you hear a Nobel Prize winner, but they got their Nobel Prize in something completely unrelated to COVID. But they never say that. They just say they're a Nobel Prize winner, and therefore everybody believes them because of it, even though they're not an expert in the field that they got the Nobel Prize in. Another big problem is publish or perish. Scientists and lab heads, they need to publish or they won't get funding from grants or things like that. So there's this big urgency to get things published just to survive, publish or perish. And so sometimes they'll say whatever they can. There's profits, of course, drives a lot of what's information you get. But a big problem is that nowadays there's a lot of people are trying to get a lot of followers, views on their social media, likes, votes. They're trying to win elections and shares in their social media. And then there's a lot of top level people that just are not very good at data analysis. And so they're seeing the data and then interpreting it all correctly. It's also the audience. Okay, all of you, some of you are probably letting some of these speakers get away with things and you shouldn't. But one of the big problems is that people tend to believe what they wish to be true. Okay, so if somebody says something like you don't have to wear a mask and you don't want to wear a mask, you tend to believe it without actually looking at the data. People have this belief in high-ranking officials. I mean, just because somebody's in a high top position in some organization like the FDA or the CDC doesn't really mean that they really know it all. It means that they are getting information from people in their things and in their organizations, and they're probably sometimes misinterpreted. And then another problem with the audience is that people tend to believe things that are entertaining. So if it's entertaining, like that picture I showed of ivermectin and the woman whose head has become a horse, that was an entertaining thing, and people believe that just because it's entertaining. Well, the title of my talk is What's Real? How to Discern Fact from Fantasy. And the first thing that I want to say is look at the data, not somebody else's interpretation of the data. So what we hear all the time in the news, social media, we hear people showing percentages of people who are infected, percentage of people aren't infected, things like this. But actually, those are interpretations of the data. Learn how to go actually look at the data. And to get started on this, I'm going to first talk about COVID, because that is the biggest thing that's going on right now, where we're getting more info. People have become more aware of misinformation since COVID than ever before. But a really easy thing to do, and just to get started here, is to just go to Google and just type COVID dashboard. You're going to find that there's a lot of different sites where people are actually presenting the data. This is an example. This is an example from my own area, where if I, type Google COVID dashboard, I can find one link that provides me this kind of information here. And if you look really close, you'll see that there's a button down there called Downloads. And when you click on that, you can actually see the raw data where people, hospitals and stuff are entering the data, and it's the raw data, and then other people are then going ahead and analyzing it. So you have access to these kind of things, but most people just don't know it. You just have to sometimes take a while to search for it. Here where I live in Washoe County, Nevada, we got some pretty good sources. But there's also, they'll have to summarize the data, not necessarily interpret it, but they'll summarize the data in a situation like shown here on the left. This is data from September 16th, 2021. We can also keep track of this data, and you can look at data from a week before. Okay, and from that data, you can do some great things. You can look and see how many new cases have there been just in the last week. You can also see how many new breakthroughs there have been in just the last week. Breakthroughs are people that have been vaccinated, and even though they've been vaccinated, they still got infected. So you can see how many vaccinated people are getting infected. And this is actually one of those things, that one of those press releases I showed at the beginning, where there's now doctors trying to get a petition showing that a lot of hospitals now are reporting a lot of, saying that a lot of cases of vaccinated people getting infected or dying are being recorded as not being vaccinated. And why they're doing it, I don't know. But that's not the point of today's talk. The point is just to figure out how to figure out what's real. But also from this data, you can figure out what percentage of infected people were vaccinated. And so you have all this data available to you. And so bottom line is look at the data. And there's more. Okay, so if you want to find out, how many people have been vaccinated and when have they been vaccinated, there's tables you can find with all the data. When you look at like a typical graph from the United States of infections, you can see things like, here's when the vaccine got released. This is pretty much at a peak. And then you can see that there was a significant drop right after the vaccine was released. But even after the drop, only 3.6% of the US was vaccinated. So what does that mean? Why did we have that drop? Okay, I don't necessarily believe that it was because of the vaccinations, because only 3.6% of the US population was vaccinated by the time we reached practically the minimum there. But again, look at the data. You can start learning what's real and what's not. So one, look at the data. But I also want to talk about peer-reviewed studies. This is a great source for finding out information. There's a lot of people, scientists publish, do research, they get data, they want to publish it, but it gets peer-reviewed first, okay? There's places where you can go to find, and I know this is going to be recorded, I don't expect people to write this down, but you can actually go to places where you can get a list of databases where you can actually read peer-reviewed studies, not just in medicine, but in politics and everything. These are two sites that I often use to find peer-reviewed journals and articles. Now, PubMed's one of my favorites because that's, I think, the best place for finding peer-reviewed medical-related studies. So peer-reviewed studies is a lot better than just looking at the data. But even in peer-reviewed studies, things will slip through the cracks. And you can always find support for things that you wish to be true, as I said before. And a classic example that is actually close to home for me because it's right in my field is these two papers. These are peer-reviewed studies that came out. The top paper right there says telomerase immortalizes cells. Okay, I'm not going to go into details what telomerase means and what immortalizes means, but the bottom line is that this paper is saying telomerase immortalizes cells. Well, this paper says telomerase doesn't immortalize cells. It says the exact opposite. The key is these are in the exact same journal, only 2 weeks apart from each other, and they have exact opposite conclusion, even though they did the experiments exactly identical. So they both can't be right. You got to go. So even looking at peer-reviewed studies, you can still reach wrong conclusions. So I recommend that you do meta-analysis of peer-reviewed studies. Meta-analysis means you actually look at the data yourself. You read a bunch of papers, okay? And you like 2 papers will have conclusion A, 16 papers will have conclusion B, 3 papers will have no conclusion, 1 paper will conclude both A and B are true. This happens all the time. So clearly, if you want to go this route, this is a little more difficult because you have to read a lot of papers, but you can find out that conclusion B actually is probably the correct one because more studies came up with that conclusion. And then if you really want to get good at this, there's what I always do is called critical meta-analysis of peer-reviewed studies. And this is actually very complicated. you need to really get trained well in experimental design, data analysis, logic, statistical theory. You need to be good in the field of study. Now, this requires a lot of homework, a lot of practice to get good at this kind of stuff. And you can resort to talking to other people. I consider myself very good at critical meta-analysis of peer-reviewed studies, which means read all the studies, but then read them in detail and then read them and see which ones don't have a good experimental design, which ones aren't logical, which ones make mistakes in statistics, and then eliminate those. Okay, so we go back to the same table I showed you before. If you do critical meta-analysis of these papers, you might say, well, conclusion A really had 0 papers supporting that. Conclusion B had 13 papers, no conclusion in 0 papers, and no conclusion for both A and B. So again, we conclude that B is the best answer. And again, there's nobody else saying anything else except for papers that are poorly designed or so. I want to say there's other people, especially in RADFest, speakers that I consider very good at this. I'm probably going to forget a few names, but like Joe Cleaver, Dr. Amy Doneen, Sandra Kaufman, and a bunch of others. I apologize if I've forgotten anybody's name, but there's a lot of people that are very, very good at doing critical meta-analysis of peer-reviewed studies if you want to talk to anybody about if you're having trouble doing that yourself. But here's what the real, so the bottom line is all the things that I just mentioned. Look at the data, do peer-reviewed studies, better yet, do meta-analysis of peer-reviewed studies, and even best of all, do critical meta-analysis of peer-reviewed studies. And the bottom line, don't be a victim of hearsay. And as I said, hearsay is hearsay, hearsay, hearsay. But it's all over. Remember the telephone game? You'd whisper in one person's ear, and then that person would whisper into another person's ear, and that person would whisper in somebody else's ear. And at the end, the last person is coming up with something totally different than what the first person was saying. We all played those as kids, but that's actually pretty much how any organization goes, including the FDA, the CDC, WHO. I mean, the data is at the bottom here. This is where the scientists are. That data gets communicated uphill to the upper levels and further up to the upper levels. So really, I'm not going to blame the top level officials. They have a big job because their job is communicating what their organization is learning. So the top of an organization like the FDA has thousands of people generating data, and they've got to be the spokesperson. The top people have to be the spokesperson for presenting that, and they can actually miscommunicate that a lot. So again, look at the data. And thank you very much.